In this video, we'll be talking about distance on coordinate plane, or the length of a segment on coordinate plane. So for instance, what if I have to find the distance between 2 points? The points are given as ordered pairs. To visualize, we're going to plot it on the coordinate plane, A, -3, 2. So the x value, -3, along the x-axis, we go left 3, and then y value is 2. So -3 to the left, up 2. That's the location of point A. Point B is located in 1, 2. So x 1, y 2. From the origin, we go right 1, up 2. And this is the location of point B. To find the distance between A and B, we need to see what is the length, or how many units do we have between A and B. So this is something that we can actually count, the number of units from A. 1, 2, 3, 4. So from A to B, we have 4 units. The length of this segment AB is 4 units. So AB segment is 4 units. We can count the number of units from A to B. How about the distance between points C and D? So first, let's plot the points. C, -1, 3. X, -1, Y, 3. So along the x-axis, -1, left 1. Along the y-axis, up 3. From the origin, we go left 1, up 3. Point D is located in -1, 0. So -1 is for x, that means left, and then y, 0. We don't go up, we don't go down, we just stay on 0. Connect points C and D, and what we have here is a vertical segment, and that is again a segment that we can count. That distance from C to D we can count. From C, we go 1, 2, 3, and that is the length of the segment, 3 units. So to record that, I'm going to say CD segment is 3 units. How do I know? We can count. The easiest way to visualize and count. Later on, we'll see the distance formula and how it applies to bigger numbers. Today, we focus on the visual aspect and what if now I have to find the distance between E and F. E is located in 3, 3. So that means from the origin +3 for x and then up +3 for y. 3, 3, 3 the x value and up 3 y value. Point F is located in 0, -1. So for x we have 0, I don't go right or left, but for y I have to go down -1. So 0, -1, point F. Once I connect the point E and F, we have this tilted segment. In other words, we cannot count it any longer. A, F, and B, on the first example, we were looking at the horizontal segment, which we can count the number of units. Then for CD, we had a vertical distance where we can count the number of units, but when we have the segment EF, we cannot count this distance. So this is when we are going to use Pythagorean theorem and the right triangle that we'll create using the grid lines of our graph notebook. So the point E in 3, 3 and F in 0, negative 1 by connecting the segment are not now a distance that I can just count. This is something that I have to solve for. So I have a few steps for us to follow. First, we're going to create a right triangle. The right triangle will have these endpoints E and F, and we can draw it above, up, and to the right to meet from point F, point E, or we can draw it below this line across and up or down and across to create this right triangle. I'm going to choose to go down, straight down on the grid line and across on the grid line to create this 90-degree intersection and the right triangle. Why do we need that? Once we create the right triangle, our segment EF becomes the hypotenuse of the right triangle, where the leg measures across here 3 and down here 4 can be counted. And then using those leg measures, we'll find the C hypotenuse where A and B are the leg measures. In Pythagorean theorem, a squared plus b squared equals c squared. So step 1, we create a right triangle. Step 2, we count the leg measures. So the leg measures are some lengths that can be counted now. And then we'll use the Pythagorean theorem to find the distance of segment EF, which in Pythagorean theorem is labeled C, hypotenuse. So starting with the Pythagorean theorem, a squared plus b squared is equals c squared. We have leg measures now 3 and 4 that we can substitute in the formula, 3 squared plus 4 squared. And we are going to solve for this segment EF, which is the hypotenuse, c squared. 3 squared, 3 times 3, 9, plus 4 squared, 4 times 4, 16, will be c squared. Add 9 plus 16, that would be 25. Inverse operation of square is square root. So to find c, we need to use the inverse operation, square root. And our hypotenuse will be 5 units. That is our distance or the length of segment EF. So now when we answer, we say segment EF, segment symbol is 5 units. So what do we have so far? We have 2 points, A and B, and the segment of horizontal line right here on the grid line, we can count. If we happen to have a vertical line and it's exactly a segment on the grid line, we simply can count. But if by connecting the given points we have a tilt, it becomes like a diagonal of a rectangle or a hypotenuse of the right triangle. So using the grid lines, we can create a right triangle, count the length of the leg measures, and then use the Pythagorean theorem to find the hypotenuse. So let's see a few more examples. Find the distance between point A, negative 2, 5. So I have negative 2, left 2, up 5 for y. Negative 2, 1, 2, 3, 4, 5. That will be my point A. Make sure I label it. Point B has 2, negative 1. ordered pair coordinates. So I have x2 positive, y negative 1. So I start from the origin 2 positive, that's right 2, negative 1, down 1. Label point B. Once I connect the point A and B, that becomes a segment. To find the distance is finding this length of the segment AB. Segment AB cannot be counted, right? So I don't have a grid line. It's not on a horizontal or vertical. It is a tilted segment. So this is when we're going to, one of the ways to find the distance is using the Pythagorean theorem. So let's find that right triangle. We can go down from A and across from B to create the right triangle this way, or we can go across from A and then up from B to create a triangle this way. The size of the triangle will be the same. So I'm going to use my ruler to go straight down from point A. See what that grid line will intersect with B. So go across following the grid line B and create that right triangle using the grid lines of graph paper. Once I highlight it, you can use colored pencils, crayons to make it stand out so you can see the size of the leg measures. So we can count 1, 2, 3, 4 units here. We can count the distance going down here, 1, 2, 3, 4, 5, 6 units. So the leg measures of the right triangle are something that we can count, but the hypotenuse we cannot. So those will be your A and B in the Pythagorean theorem, and the segment AB will be the hypotenuse C. So starting Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the leg measures and c is always the hypotenuse. Substitute the values, 6 squared plus 4 for b squared equals our hypotenuse squared. Squaring the number means multiplying by itself. 6 squared, 6 times 6, 36. 4 squared, 4 times 4, 16. That equals c squared for now. Then we add our values, 36 plus 16. And this is not a perfect square. So to find, let me put my calculator here so you can see. You can use a calculator online. If you just type in Google the word calculator, it will pop up for you. You can use any calculator to help yourself. So we need to do the inverse operation to find the value of c. Inverse operation of square is square root. So we need to find the value of square root of 52. We can estimate that is 7 point something because it's past square root of 49. Let's see it exactly on calculator. So square root of 52 is 7.2 approximately. And I'm going to put it here, 7.2. And I see that the hypotenuse is longer than the leg measures. Hypotenuse is always the longest side of the right triangle. So sometimes the answer can be recorded as root if it is not a perfect square, or estimated to a decimal. It depends on what the problem is asking you to choose from if it is a multiple choice. So as an answer, again, I can say that segment AB is square root of 52, which is not a perfect square, approximately equal to 7.2. Finding the distance between points C, 1, 1, so positive 1, right from the origin and up 1 unit. D is negative 3, negative 4, so we go left 3, x value, x goes left, left 3 from the origin, and then down 4. So negative 3, negative 4, left and down, D. By connecting the points C and D, we have a segment. The length of that segment cannot be counted, but it can be solved using Pythagorean theorem. In order to do that, we need to create a right triangle. So what do? We can create a right triangle by going up on the grid line and across to C, or down from C on the grid line and across to D. I'm going to go up this time just to show you. So if I go straight up and see where that meets with the segment across, highlight or color in or shade in your right triangle to make it stand out so you have the numbers to focus on. Counting the leg measures, 1, 2, 3, 4, 5. 1, 2, 3, 4. And then using the leg measures and the Pythagorean theorem, we can find this hypotenuse C. In formula, a squared plus b squared, we have leg measures. C is the hypotenuse, which is our segment CD, or the distance that we need to find. Substitute the values in our formula, so the leg measures AB will be 5 squared, 4 squared equals hypotenuse squared. 5 times 5, 25, plus 4 times 4, 16, equals c squared. Then we add our measures. 25 plus 16, 41. Inverse operation of square is square root. So when we find the value of the hypotenuse, we need to use inverse operation, square root. Square root of 41 is not a perfect square. So when we record our answer, we can say that segment CD is square root of 41. So you can actually answer it as a root. If it's asking in the problem for you to estimate or give an approximate value to a tenths or hundredths place, then we can estimate it by using the number line. 41 is past square root of 36, so it should be 6 point something. On the calculator, we have 6.4. Rounded to the tenths place. If I look at my triangle and say this value is approximately 6.4, and the hypotenuse is the biggest number out of the three measures. Like measures are always shorter, hypotenuse is the longest side of the right triangle. Let's see one more example. At this point, you can pause the video, maybe do it on your own, see if you can come up with an answer, and then play the video to see if I show the same result. Or go along with me. So let's determine the length of the segment DF. If points D, -4, 3, and F, 4, 1, are on the coordinate plane. So let's connect point D and F. That is a distance that we cannot count, but we can determine that distance using Pythagorean theorem. In order to do that, we have to create a right triangle. That right triangle can be created by going straight down using the grid line to where the distance across will intersect and create the right triangle. Shade in the right triangle that was created. Make sure that it's a right triangle. So using our grid line, from point D, we go down from F across and create that 90-degree intersection. Then we can count the leg measure 2 and 1, 2, 3, 4, 5, 6, 7, 8. Those will be the AB, and then we can solve for the hypotenuse C. Using Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the leg measures and c is the hypotenuse. In the formula, leg measures are on the same side and hypotenuse is the longest. So substitute the values. 2 squared plus 8 squared will be our hypotenuse squared. 2 squared, 2 times 2, 4. 8 squared, 8 times 8, 64. Adding 4 plus 64 is 68. And then don't forget, to find the hypotenuse, we need to inverse the operation square, which is square root. And that could be an answer if it is left in root form. So the segment DF is square root of 68, which is not a perfect square, but it can be either estimated or found on the calculator. So it's almost square root of 69, past square root of 64, which is 8. So if it's past square root of 64, which is 8, should be 8 point something. Okay, let's see how much is that. 68 square root 8.2. So it's slightly past square root of 64, which is 8. So it's 8.2, approximately rounded to the tens place.